Yes.
Okay, perfect. So I'm assuming you guys have already gone through the setup to set up your workshop. As a reminder, welcome to the Python for Data Science workshop. If you're not aware, Python is kind of the standard nowadays for a lot of data science work. There's also R, but by and large, Python is pretty much the most popular language whenever it comes to anything having to do with data. So that's data analysis, that's statistics, and most importantly, machine learning. We're not going to go into a lot of machine learning topics this workshop. That'll be covered by my friend John in our next workshop, the machine learning workshop. So he'll be covering things like TensorFlow. But for now, we're going to cover the foundations of data science with Python, which is Jupyter notebooks, Pandas, NumPy, and what's the other, Matplotlib. So I'm going to go through the setup real quick, just for anyone who hasn't already done it. So first of all, with the Visual Studio Code window open, you're going to do the Control-Shift-Grave command, or a shortcut. If you don't know what the grave key is, it's that little key next to the one that has the tilde that nobody ever presses. It's that one. That'll open up your terminal. From there, you're going to clone the repository for the workshop, and you're going to change directory into that repository that's created. So Data Science Workshop. And once you've done that, you're going to install the requirements for this workshop. This, of course, assumes that you have pip installed, which is the Python package manager. If you try that and it tells you that pip isn't a command, it means you didn't install Python properly. If you get that, find the Python installer, go back, rerun it, and make sure you click modify, and then you go in and make sure that you add Python to the environment variables. So once you've done that, everything, all the requirements should install properly. It might take longer because you have to download all these other packages as well, but that's how that works. And once you've done that, you can go here, open up the folder, go to the root folder, which is usually where it's stored, and you'll find the workshop here. And there you go. You'll see the files on the side. So data science isn't that complicated, but there are just a couple rudimentary basics you have to know before you get into it. Just some basic math and algebra. So we're going to get through it here real quick, just in the next 15 minutes or so. So the first absolute beginner basic concept you have to be familiar with is grid. No, I'm just kidding. We're not doing this. No, that's an old machine learning assignment. Here. Okay, here's the real workshop. So data sets and visualization, okay? So your first rule of data science, okay? Look at your data. A lot of times people will try and manipulate their data without actually knowing what it looks like, and they just stumble blindly for no reason. Second of all, look at your data. Like seriously, it's important. You want to be looking at it. There are a lot of really, really good data sets and APIs that you can use to get some good data. One of the best places you can get a lot of these data sets is on Kaggle. Yes, James, this will be uploaded online once we've got the recording on the UPE YouTube. So once that's uploaded, we'll send you a link, okay? So there's Kaggle, which is basically a hub for a bunch of data sets online. You go to Kaggle, you'll see data sets for everything. There's data sets for how long people have biked over certain days, depending on the weather. It's insane. So we're going to be using, for this example, the Ames set, which is a housing price database. There's machine learning databases, and there's also the Google Dataset Search, which are just as useful. So first of all, you have to import some basic packages. Now, before we jump into it, I'm going to explain a little bit of what everything does here. So if you did the prerequisites and the installation property, you should have this notebook open. What this is a Jupyter notebook. A Jupyter notebook is essentially just a series of cells. And in each cell, you have self-contained little bits of code that can influence code that comes after them. So if you declare a variable here, you can access it here. And the cells can also be marked down instead of code. So you can get these really nicely formatted marked down documents with code embedded in them. And then you can run cells individually by pressing this run cell button up here. So we're going to run this cell right here to import all these important things. I'm going to explain a little bit of each of them top to bottom. First of all, this line here, matplotlib inline, that is what's called a magic line in Jupyter. And what that does essentially is it tells matplotlib to display the graphs inline in the actual document. PyQt5 is a graphics library. That's what will allow us to view the 3D plots and actually spin them around and pan them and everything. NumPy, it's usually abbreviated as NP, which is why we use the as symbol here, because that way, if we need to do something in NumPy, instead of typing out the entire name, we can just type NP, and it's a lot simpler and easier for people. It's a numbers library. It lets you do a lot of scientific numbers things. It lets you get ranges of numbers. It's basically just a general purpose scientific math library for Python. Matplotlib is the library that we use to show graphs. So it's a general purpose, really versatile library that you can use to display a bunch of different kinds of plots. You can do box plots, you can do line plots, you can do 15 different plots on one page. There's a lot of different things you can do with Matplotlib. We're just going to go into the basics of how to use it in this workshop, but if you get into it, you can make some really pretty graphs with Matplotlib. There's also this, which is the animation library of Matplotlib, and PyPlot, which is important. This part here imports the actual plotting library of Matplotlib, and we abbreviate it as PLT. So whenever you see PLT in the following code, we're talking about Matplotlib's PyPlot library. Same thing here with the axis 3D. So on the single 3D plot we have here, it's just so we can see the 3D plot. And lastly, Pandas as PD, abbreviated as PD. What Pandas does, Pandas is essentially the interface between our data and Python. It allows us to read large data sets into Python data structures that we can then address really easily. So as opposed to having to write our own code to manually read a CSV and get all the data from it, Pandas does that for us. So now that we've gotten through what all these things do, let's start getting into the data. So it's really easy to download data with Pandas. Literally all you have to do is put a URL, read CSV using Pandas with the URL as a parameter, and that will be output into a data frame. Here we've abbreviated that as DF. Now, don't confuse a data frame with an array. A lot of people will try to address data frames like they're arrays, but unfortunately that just doesn't work. It's its own kind of Python object, and one of the methods on that object is head. What head outputs is just basically the data in here. So if we run it, it'll fetch the Ames residential home sale data set, and it'll show us the data that it just fetched. If you click run cell on this after you've run celled here, you have to run these cells in order, by the way. If you run this and then you run this, you should see this data pop up. If you don't see this data pop up or you see an error, let me know, because that means something's gone wrong. So we have some data. That's cool. So just to show you the basics of how plotting works in Matplotlib, we're going to look at two-story houses sold in 2010, and we're going to see if we can plot some relationship between the size of the lot of a house and its price. So here, for example, let's we have this magic here to basically tell Matplotlib to plot the plot inline, as in the notebook, not in a separate window. And from top to bottom, let's explain what we're doing here. So once you get the data frame, we want to filter out specifically only the houses that are sold in 2010. Okay, so to do that, first of all, we'll make a filter here. And what this lets us do essentially is get only the rows where the subclass is equal to 60, which is basically just saying if it's a two-story house, and if the year sold is in 2010. Okay, so this Boolean statement altogether is assigned to the variable index to br 2010. Then we use that filter, that Boolean, to essentially only get the sales prices and the lot square footage and the bedrooms of houses that fit these requirements. So this is basic Python stuff here. One of the features of Pandas actually in data frames is you can filter columns based on Booleans like this. And you basically do it in a second subscript just like this. It's really handy. It lets us only grab the data we want. So after we've grabbed our filtered data for only two-story houses sold in 2010, right? We have the bedrooms, we have the frontage, we have the sales price. So the next thing we do is we create a new variable called figure, and we create a new figure using the PyPlot library from Matplotlib. Remember, we abbreviated that as PLT. This creates a new figure and assigns it to figure. Now, let's explain this a little bit. So in Matplotlib, there's a concept of figures. And then within figures, there can be multiple subplots. And each subplot is just a plot of data. So we've created our figure, and now we need to create a subplot. So we're going to create a subplot here. 111 just basically means that it's just one subplot in the top left corner. And we've assigned that subplot to the variable ax. So now, when we want to plot our actual data, we're going to do the ax.scatter function to do a scatter plot of the lot size versus the house price. And then just to format the table a little bit, we're going to address PLT, the PyPlot, set the X label to lot size, set the Y label to price, set the graph title to price versus lot size, and then show the graph. And when we run this, we'll see this pretty little graph show up. I'm hoping everybody saw this graph. If not, please raise your hand in there or just say something in the chat and we'll check to make sure everything's right. So looking at this data on this graph, we can already see that there's kind of I mean, a little bit of a correlation, but it's kind of weak. You can roughly see that around lot size 60, the price is normally lower, and around lot size 100 to 110 is a little bit higher. So that's roughly a correlation. You can kind of see that. We're going to look at some clearer data later. So next, we're going to look at the relationship between the number of bedrooms in a house and its price. So remember, we already have price, lot, and bedroom in their own data frames here that we've separated out earlier. So we're going to create another figure now. We're going to do a scatter plot of bedroom and price. And notice what we're doing here. We're not using acts this time. There's two separate ways of doing this. You can do add subplot, which allows you to have multiple plots in one figure, or you can just do plt.figure, and it'll simplify things for you if you only need one plot in your data. So we're going to plot the bedroom versus price. We're going to do the X label bedrooms, the Y label price, and the title will be price versus bedrooms. And you can see here a pretty somewhat linear relationship as well. So the 3-bedroom houses, their median price is around, let's say, what, 250,000. The 4-bedroom houses, it's probably closer around 300,000. And you can see this one outlier way up here. Next is a really cool part. One of the cool things you can do with matplotlib. We have these 3 variables. Now, what if we wanted to plot all 3 of them? Normally on a 2-dimensional plot, obviously you can only plot 2 variables, the X and the Y axis. But with a 3-dimensional plot, you can actually plot more of them. So here's how we'll do it. Matplotlib again inline to make sure that the plot is drawn in the notebook. We're going to create a new figure. We're going to add a subplot. And this time, what's important here is that we're setting a variable, projection, to be equal to 3D. With Matplotlib axis objects, setting the projection to 3D basically means now it's a 3D graph. And then we're going to do a 3D scatter plot with our 3 variables here: the bedroom, the lot price, the lot size, and the price. Again, we're going to set the X label to bedrooms, the Y label to lot size, and the title to price versus lot size and bedrooms. And then we're going to show the graph. Block.equals true just means that it'll wait for us to see. And we can see our 3D plot here. And this is nice, but if you're like me, you can't see in 3D when it's a 2D object on your screen and you're kind of wondering which dots are where. I mean, it's nice. So that's where the magic comes in. Remember what I talked about magic commands? Inline isn't the only option you can pass in here. And this right here is the reason why up here we installed PyQt5, a graphics library. So going back down here, we'll create a figure. We'll set the projection to 3D again for the subplot. We'll do the scatter, but this time, notice our magic is Qt. This is the only difference between these 2 blocks of code. Otherwise, they're completely the same. This Qt here. We're going to scatter plot of bedroom, lot, and price. We're going to set the X labels, the Y labels, and the title. And when you click run, a new window should pop up. I'm not sure if this is showing over the Zoom properly, so let me set this to window share instead of desktop share instead of window share. So hopefully you guys see this now. And now with the new window that popped up, you can actually click and pan the data to see exactly where on the 3-dimensional axis it lies. So we see here the Y-axis up here is the price and the X-axis is lot size. And if we angle it like this, you'll notice it looks just like our 2-dimensional data right here, you see? And then if we do the same thing with this side, or better said, like this, you'll notice it looks just like this 2D plot. We're not only limited to scatter plots, by the way. You can do some really, really cool things with matplotlib. You can do plots of surfaces, you can do heat maps, you can do a lot of really powerful things with this tool. This is just a basic introduction to show you how you can do these things. So we'll exit out of that and we'll automatically continue on to the next cell. So that was housing database. It's cool. I mean, yeah, you know, housing data, it's interesting, but there's cooler data we can look at. So there's more straightforward data as well. So now let's take a look at another data set, the archive of car efficiency data here. So our URL here is from uci.edu, the machine learning database they have for highway miles per gallon of old cars, I think from 1985 or so. So we're going to run this cell here to get the data, and we're going to show it, and you're going to see the data from these cars. Alfa Romeos and Audis are at the top because it's sorted alphabetically. And then we're going to do the same thing here. So we're going to turn the magic back to inline because we don't want every single graph to be showing in a separate window, only the 3D ones so we can pan through them. Inline here. We're setting n to 50 so we can take the first 51 values because remember, we start at 0. we're going to take the values out of this new data frame we just created. So we do D equals df1 values. And what this does is it actually gives us an array, I believe, that we can then work with a little bit easier. We're going to look here. We're going to see these datas here. We're going to see 23 and 24 are the column numbers for city MPG and highway MPG respectively. So we're going to encode that here just to make it easier on us. And then we're going to create a new figure. Within that figure, we're going to create a new subplot. And then we're going to scatter the city MPGs of the first 50 cars in the list and the highway MPG of the first 51 cars in the list. This does a slice. If you're not familiar with what slicing is, Python essentially lets you slice into arrays to only get certain parts of them. And the way you do that is you do the start index, a colon, and the end index of the slice you want. So this effectively evaluates to 0, 51, or 50, which will give us the first 51 values of D, which is the values array from the data frame. And then we're going to do city MPG to filter to only get the city MPG column, which as you'll remember is column 23, which is this column right here. The same thing with the highway MPG. We'll do the labels, we'll do the title, and we'll show the plot, and that will look like this, which is a lot more straightforward. The hypothesis is if the city MPG goes up, the highway MPG should go up as well, because cars in general, they just become more efficient, and then both of those numbers go up. And if we look at this, then the hypothesis seems to hold. It makes sense. We can actually plot a line to this if we wanted to using linear regression. That, however, is a machine learning topic, and we're not going to talk about that because that is firmly in John Quidogram's territory. But you can pretty easily imagine how you could plot a line to this. It doesn't take a rocket scientist to see what line fits this best. Now, here's the meat of the workshop we're getting into. So these last two data sets, we're just showing you what pandas is, how you can read a CSV into a pandas data frame, how you can plot a pandas data frame onto a scatter plot using matplotlib. Now, let's take a look at some COVID-19 data, which is really relevant to what we're doing here at PantherHacks. So first off, this data is really important because a lot of policymakers and government officials are looking at this data to make day-to-day decisions like, for example, not being able to go out past 10 o'clock or not being able to go to the beach. So it's really valuable that we see this data so we can see exactly what is justifying their decisions. So the EU has published a public data set of global COVID-19 case distribution. So we can go ahead and get that really easily from this URL right here. We read it into a pandas data frame. This time we're going to call it df2 so we don't conflict with the other data frames we've used before. And we're going to display the head just to see what the data looks like. This one will take a little bit longer just because it's a lot more data. But it's not too much data. It should take around 10 seconds. Perfect. We see the data here. We can see the structure of the data. We can see the columns. We can see the dates, the days, the months, the years, the cases, the deaths, the countries, and so on and so forth. So now that we have this data, let's define a function. So previously, we've just been hard coding every single graph we do, but we can also make a function in Python to make writing graphs easier for us. So in Python, if you're not aware, you declare a function with the def keyword, the function name, parentheses, and then the names of the parameters you want to take in. Python is a weakly typed language, which means we don't have to specify the type of the array here. We don't have to do that. We can just do countries, and then it'll sort of figure it out on its own. So what this function will do is it'll take in a list of strings representing countries. It'll create the figure. It will create the subplot within the figure. And then for each country in the list of countries, we will create a filter here. So just like we did with the housing data sets where we made a filter to only show two-story houses built in 2010, we're going to filter this data here to only show data that matches the country we're looking for, because this data set has data from all countries. Next up, we're going to do the same thing for the case numbers. So we're going to be filtering the date column and the case number column, because those are the only two columns we're interested in right now. Next, we're going to plot those two arrays onto a scatter plot. No, that's a line plot on axis. With this bit right here may be confusing some people. What we're doing here essentially is we're just reversing the order of the data, because you'll notice if we don't have this and we run the graph, you'll see it's backwards, because obviously we didn't start with 80,000 cases a day. So we put this in here to reverse the order of the data because it's just the way it's encoded in the data set. And we're also going to add the label flag, which basically means for every country that we add, we're going to label its line on the graph. If we didn't have this, you would see there would just be 4 lines with no labels, and it would be a little bit harder to read. So that's what that flag is for. See? And lastly, we're going to do ax.legend, which for a subplot, the .legend command actually draws this legend here on the side. So if we didn't have this, for example, there would be no legend here, and it would be the same thing. So that's what that does. Now, this bit here is just a little bit of math here, because if we didn't do this, then you'll notice the UK has one day where for some reason they have negative 80,000 cases. And if we don't deal with that here, it just throws the graph completely off. And I'll show you what I mean here for a second. If we comment out these 2 lines, it just looks ridiculous. There's like a huge spike here where the UK's case numbers go way down. So to fix that, we set a Y limit on the plot. That's what ylim does here. And the first number that you pass into ylim is the lower limit, and the second number is the upper limit. So basically all we're doing here is we're getting either negative 1,000 or the smallest number in country cases, whichever one is small. And then the max is either the highest point in the graph previously or just the highest number of cases in the data set. So we don't have way too wide of a window. And it ends up looking like this, which looks very nice. We also make sure that the scale is linear. If we don't do this, you'll notice that the graph basically just becomes unreadable because we get an absolute crap ton of labels down here that is just no, we don't want that. So that's why we set the scale to linear for the x-axis. You can also use other scales if you're familiar with statistics, like logarithmic for really large data sets to make it easier to read. Lastly, once we've defined this function to show a graph for a series of countries, let's go ahead and show the daily cases reported for Japan, the US, Germany, and United Kingdom. And as you can see, that looks like this. Now, one of the cool things about the Jupyter Labs extension for VS Code is you can actually click on the graph and go into the plot editor. And in here, you can zoom in a little bit by, control scroll up, scroll down with these things up here. And you can even save them if you wanted to a separate file and then use that in a document or something that you're doing for a class. So it's really useful and really handy to have. Now, this is nice, this is good, but if you're aware at all of statistics or statistical biases, you'll notice there's a little bit of a problem. We don't know for certain whether this huge number of infections from the US is because the US is actually doing worse or just because the US has more people. We're not entirely sure. We can very clearly see that the US has an enormous number of cases reported compared to these other countries, but we're not exactly sure why. It could just be because of population differences. So let's investigate. All right. So you'll notice there's another column here in the data set. It's cumulative number for 14 days of COVID-19 cases per 100,000. That's one hell of a label, my God. So this basically is a per capita number that we can use to more accurately represent the cases in the countries, but I'm getting ahead of myself. Let's ignore that for now. Let's look at the population statistics, because there's also a population data column over here, which tells us the population of the country from a census in 2019. Now, for each row a country has, this number is the same, so we only need to get it once. So let's do that. We're going to create another function here, this time to display population instead of displaying cases. So in this function, it's basically just a modified version of the previous function. We're going to create a figure. Within that figure, create a subplot so we can show this stuff. And then we're going to just create an empty array called populations. And then for each country in the list of countries, we're going to create a country filter just like we did before. We're going to filter the population data column by the country filter so that we only get the population for the countries we're caring about. And then we're going to just yank out the population number from country pop. And I just realized it says country pop. My God, I hate country pop. So we're going to get the country pop of the country we're looking for. And the .iloc function here basically just lets us address this data frame as if it were an array. So we're going to get the value at the 0th position of this data frame. Because remember, this isn't an array. This is a pandas data frame. Once we take that function, that value out of there, we can then append it to populations. The end result is this array will just have the population of each country in the lists. It'll be a one-to-one correspondence. Next up, we're going to go to the subplot. We're going to rotate the ticks on the x-axis by 45 degrees. And then we're going to create a bar chart. So notice previously we've done plots. Plots are just lines like these. If we scroll up even further, scatters look like these with the dots. If we do a bar graph, it'll actually show like this, which is really handy. So you can see the 45-degree rotation of the labels that are easier to read. And now that we're looking at the graph here of the populations for each country, we can pretty clearly see that the difference in infections can't be explained completely by population, because Japan has a population of roughly 125 million people, while the US has a population of over 300 million people. So that's a difference of only around 2.5 times. But if we look at the case numbers, we can see a lot more than 2.5 times the number of cases in the US versus Japan, which let me remind you is this blue line here. So to verify once more that the US is doing worse, and not just because of population differences, let's make one more observation here. So remember what I was talking about this field before. This is the per capita infections per 100,000 people for over 14 days. It's a rolling average. And this right here, this variable is independent of the population, which means if a country has a very large number of this right here, it doesn't matter the population. You can tell that country is just doing worse. So let's get that value from the data set, okay? So this is one more time a modified version of the previous function, which is we're going to create a new figure. We're going to add a subplot to that figure. For every country in this array of countries, we're going to create a filter for the country to only show data relevant to that country. We are going to filter the date rep column in this data frame using that country filter to only get data for the countries we're looking for. We're going to filter the, God, this is such a long label name, the cumulative number for 14 days of COVID-19 cases per 100,000 column using the country filter. And then once we've done that, we're going to plot the the x-axis will be the number of days, and the y-axis will be the averages this time, not the number of new cases, but the average number of cases over the last 14 days per 100,000 people. And once again, we're going to do this little thing here to reverse the order of the data, because otherwise it'll show backwards. iLock. This bit right here, if you're confused, if you're not a Python person, is also slicing. So slicing, I'm going to go into a bit of a tangent here, but slicing, you do, as you'll recall, the begin index, the last index, and there's a third variable you can pass in. And the third variable is the step size. So if I were to put 2 here, this would give every second number from the beginning to the end of the variable. If we put a negative number in here, it actually lets us traverse the array backwards. So it's very easy, very handy for just reversing an array whenever you need to. And lastly, we're going to put the label of a country so that it's labeled as it makes sense. We're going to do the same thing here to normalize the data, which is just get the highest of either the averages or just the highest point that already exists in the graph, and do the same Y limit here so that the UK data doesn't skew everything. We're going to set the X label, we're going to set the scale, we're going to set the Y label, we're going to set the title, and then we're going to show the graph once it's done. And lastly, we're going to call a new function, passing in once again Japan, the US, Germany, and the UK. And if we run it, you'll see, finally, conclusively, we can say that disregarding population differences, disregarding everything, you can very clearly see that the US is doing a lot worse than all these other countries. Because you can see here, it's actually kind of sad. You can see that first initial spike we had around, what, March or April, slowly tapers off, and then whoosh, there it goes. Versus Japan, which our main question before was, is the difference only because of population? We can see clearly now that it's not, because Japan's per capita infection rate stayed basically the same, versus the US is just keeps going up. The UK's went down, had a bit of a spike because of a data correction, and then kept going down. And Germany had a big spike early on, kind of like the US did, but the difference is they kept it down, as opposed to the US, which shot right back up. So that's basically it. That's matplotlib, that's numpy, that's pandas. It's not that difficult. And the beauty of the IPython workshops, or the IPython notebooks, the Jupyter notebooks, is you can just experiment with code right here and see your output in real time. So it's just a really handy tool to have whenever you want to plot data easily. And for machine learning, it's invaluable, which is why I highly encourage anyone who wanted to take the machine learning workshop to make sure to pay attention to this one, because it's pretty important. So we're pretty much 30 minutes short. There's not anything else in here unless you guys really want me to go through the gradients and Hessians workshop, which I'm guessing you guys don't. But I'll open up the rest of the workshop to questions, or if you guys couldn't get something to work, go ahead and ask, and y'all can unmute yourself now. Go ahead. All right, I think that pretty much wraps it up. So if anyone has any questions, last chance, or if anyone is curious about what matplotlib can do, last chance. Otherwise, I think we're pretty much done here. There are some other cool things, now that we have, wait, someone unmuted themselves. Go ahead.
I was just going to ask if you know anything about other data code like languages like R, for instance, and how that might compare to using something like Python.
So I'm not exactly aware of the capabilities of R in relation to Python. What I am aware of is that a lot of the most industry standard machine learning code, like TensorFlow, like PyTorch, all those are focused and based around Python, as well as the IPython and Jupyter Notebook environment is exclusively for Python. So if you tried writing R code in these notebooks, it just wouldn't work. That alone is one of the biggest draws of Python to me, the fact that you can work in these notebooks like this. And it's just extremely useful to have for these sorts of things.
Thanks.
Of course. The beauty of this is you can just throw down some code and experiment with whatever you want, really. So if we wanted to, we could just, oh, what happened there? We could just create a new figure. We could create a new subplot in that figure. And then we could literally just plot the sine function. So let me recall how to do that exactly. But you can literally just plot a sine wave if you wanted to. You can plot basically any function. So in this case here, we could do, yeah. So in this case, we would do, I'm going to introduce you guys to another couple features of NumPy. So as I said before, NumPy is used for, or NumPy, I don't know. NumPy is used for scientific computing and basically just the quick, easy, like science math stuff that you need. It has a better version of the log function, for example, and it has a really useful function called linspace. So what linspace does is it allows us to go ahead and get a, actually, no, we're not going to use linspace for this. We're going to use something else. We're going to use arange, which is essentially, it's pretty similar to linspace. So we're going to create a variable called x here. We're going to use numpy, which is np, as you remember before, and we're going to use the arange function. And what the arange function does is kind of like slicing in Python. It lets us do just a range. We put the start of the range, we put the end of the range, which in this case for the sine function, let's go ahead and do 4.pi. And one of the cool things about NumPy is it has pi to an absolute crap ton of decimal places. So that's one of the things it's useful for. And then we'll do a step of 0.1. This will give us a range of x values from 0 to 4 times pi with a 0.1 difference between them. For y, we can just do the sine function. This is another thing NumPy is useful for. You can just literally do the sine function like that. It's super simple. And then lastly, we will go ahead and, let me see. Yeah, we'll go ahead and plot the x and y, and we will show the plot like this, question mark. Will this work? Let's see. Yeah, just like that. It's pretty simple and easy. But of course, there's more we can do with that. So if we wanted to, we could do another sine wave here, and then we could plot the 3 variables here, and that doesn't work at all because I'm stupid, but let's see. If I recall correctly, you have to set the, as I said, the projection here to 3D. So if we do that, that should allow us to go ahead and work with it. In the, let me see. Yeah, we set the projection when we're creating the subplot right here. So we go ahead and do that. And then you can see a 3D sine wave, just like that. We can go ahead and throw the magic in there as well to allow us to go ahead and drag around the graph. And when we do that, it'll kind of jump around a little bit. It's weird. I don't know why it's, oh yeah. we have to do block equals true. This will block it from closing until we can interact with it. Otherwise, it'll just close instantly. And we have a 3D sine wave. So resources I would recommend for data science best practices. I highly recommend the matplotlib documentation. I'll go ahead and throw that to you guys in the Zoom chat. So let me see. Yeah, so here's the documentation for matplotlib. So Luisa is asking me a question. To install the requirements from this workshop, you follow the instructions on the PantherHacks live page for the Python for Data Science workshop. If you haven't installed it, sorry, it's kind of too late because we're done with the workshop. But you can just follow these instructions there to install the required packages, and then you can go through this notebook on your own time. Yeah, otherwise, that is pretty much it. So let me see, something else we could do here. We could do the cosine of x and see what that looks like. And that gives us a cool little spiral here. So it's just, there's a lot of cool things you can do with matplotlib, not to mention just, not the least of which is just plotting your data in a really cool and interesting way. But you have your sine wave here. You can do a little spiral. You can do a cardioid if you wanted to. It's just really useful, really good to have. So I'm not going to keep you guys any longer. Go ahead. If you have any questions, feel free to ask. Otherwise, I'll close the room at 9:40. Thanks for coming, guys.
Okay, cool. Thanks, Matt. Great workshop. Just one other thing to mention. The next workshop that we're going to be having is the machine learning workshop, which should be at 10 p.m. So if you're interested how you could use this, all these different types of data to make predictions and come up with results, stay tuned for that. It's going to be a really awesome workshop. Thank you, guys.
So James, good question. Why did the UK line go below 0? So at a certain point in their data set, if you look at the data manually, you'll see that they must have done some sort of correction to correct cases that weren't actually COVID-19 or something, because you can see that they had a negative 30,000 or 40,000 case number a couple days. That's actually one of the cool things about looking at data. You can see weird trends like that and then ask yourself questions. So that's might be something you want to investigate further. All right, you can close it now, Charles. Thanks.
All right, no problem.